6, Module 6.3, talk about areas of polygons. So in this lecture video, I'm gonna kind of show y'all these basic 5 polygons that we normally encounter and show you how to find the area for them. And then we're gonna take a look at our composite figures for areas. So we did mention something about composite figure before in terms of perimeter. So in this video, I will show you how to find the areas for those. So let's take a look at these polygons. So triangle. Triangle actually comes from a parallelogram. So let me introduce parallelogram. So any four-sided shape is considered as a quadrilateral. Specifically, one of them is called parallelogram. So parallelogram is where all the opposite sides are congruent, all right, and all the opposite sides are parallel. And in parallelogram, okay, we have a base and we have a height, and the base and the height is always perpendicular. Okay, so in order to find the area, okay, generally speaking, to find area of any shape, all we have to do is see how long the base is and times how tall it is. So therefore, the area formula for parallelogram is simply base times height. Now, if I will cut my parallelogram diagonally, okay, if I will cut my parallelogram diagonally and just take a look at half of that shape, the half of that shape is a triangle. Therefore, when we find the area of a triangle, okay, since it's coming from a parallelogram, which normally area of a parallelogram is base times height, so half a parallelogram is actually the same as the area of a triangle. So the half, okay, in the area formula for triangle comes from being half of a parallelogram. All right. So under parallelogram, so let me write this down real quick. So any four-sided is called a quadrilateral. And under quadrilateral, okay, we have any four-sided shape. One specific one is called parallelogram. All right, under parallelogram, then we have something called rectangle and our square. Okay, so the characteristic of a rectangle and a square is going to be pretty much the same as parallelogram. So we know normally when we see a rectangle, okay, all the opposite sides are congruent and all the opposite and also parallel. All right, so for rectangle, we have our base, we just call them length, our height, we just call them the width. Okay, but we're changing what we call them is because that's how we can distinguish our shapes. So base times height, we know that's parallelogram. So when we have area of a rectangle, we just call them length times width. Okay, that's how we classify them as rectangle. All right, square. Square is just another one of those parallelogram where the opposite sides are congruent and parallel. To be more specific with the square, all four sides are congruent, the same length. So rather than call them base and height again, we just call them side and side. Right? Now, another specific shape on the quadrilateral is called trapezoid. Okay. So trapezoid, trapezoid come in different forms. The key characteristic of a trapezoid is trapezoid has two bases that are parallel. One base is just longer than the other base. So we have a big B and little b. I think the textbook called them B and C. I just call them big base and the small base. All right. So as long as I have two bases that are parallel, even though they are different lengths, that's okay. But they are actually, the key characteristic is they are being parallel, and the height is always going to be perpendicular to the bases. All right. So the area formula for trapezoid is always going to be half times the height times parenthesis big base plus the little base. Okay, that will be the that will generally be the area formula for trapezoid. Okay, I will introduce circle, the area of a circle, in a different lecture video. For any other type of polygon, maybe like a pentagon, hexagon, to find the area for those, we will actually learn how to do those in our geometry class, which is Math 168. For those type of polygon to find area, it's a little bit different than these basic 5. All right. So when it comes to the composite figure for areas, okay, we will either this composite figure is either two shape, okay, placed right next to each other, which means we will add the area to find the total, or it's actually a shape, okay, a shape within a bigger shape where we cut out, okay, the shape that's within. So in that case, we will actually subtract, we will take the big area, subtract what's inside of it. So that will give me the remaining shaded portion. All right. So there are two different types, okay, shape beside a shape and the shape within a shape. All right, find the area of the following figure, the indicated dimension. So the easiest thing to do here is to figure out what shape they are and determine, okay, whether I should add or subtract the area. So for this problem, to find the area of the composite figure, I see a rectangle just based on the dimension, 13 by 10. So this is a rectangle plus, to the right of it, there's a triangle. So I'm going to write down their shape. I'm going to write down their area formula. And you can look this up as well on the formula sheet. So the area of a rectangle is going to be length times width plus area of a triangle, or from the previous slide, that will be half times the base times the height. So write down the formula and then we can just fill in the numbers. So let's look at this rectangle part. Length is 13 times the width, which is 10, plus half is the same thing as 0.5 times, all right, the base of the triangle. This base of the triangle is the same as the width of the rectangle, so that's also going to be 10 times the height, okay, of the triangle, which is indicated as 10. So we write them all out and then we key in the calculator all at one time. All right, sorry about that. Make sure that was on. So 13 times 10 plus 0.5 times 10 times 10. All right, that would be 180. So for module 5, you notice that whenever we talk about area, that means our units got to always be squared. So my answer, 180 square inch. All right, let's try this one. Mary is planting a five-sided lawn, as shown in the figure below. The lawn consists of 50-foot by 10-foot rectangle and attached 30-foot high triangle. So this, again, this is actually taking a rectangle down here, all right, add on to the triangle up top. So I'm going to go up here and I'm just going to copy exactly what I wrote in the first two lines and I'm going to paste it down here. All right, so let's take a look at our rectangle. Our rectangle is 10 foot by 50 foot, so that would be 50 times 10 plus half, okay, half times base times height for the triangle, that's 0.5 times, all right, this dashed line is the base of the triangle up here, and this is the same as the length of my rectangle, so that must be 50 feet. So that's 0.5 times 50 times the height of our triangle, which is 32 feet. All right, so once I write them down, I'm just going to punch in a calculator real quick. 50 times 10 we know is 500. Plus 0.5 times 50 times 32. So I'm going to let the calculator do all the hard work for me. So that would be 1,300. My units, they're in feet. So since I'm talking about area, so that would be 1,300 square feet. All right, step 2 says if 1 pound of grass seed will do will cover 10 square feet, how many pounds will be necessary? So since I have a total of 1,300 of those square feet, every pound will do 10. So if I divide it by 10 square feet, that will tell me how many pounds that will be. So divided by 10 means move my decimal to the left one time. So that will be 130 pounds of grass seeds. All right, try another problem here. So this one here, find the area of the following figure with the indicated dimension. Note that the figure representing geometric shape with a hole. So there's a hole right here. So what I'm looking at here, this big old shape is a rectangle. All right, and I need to find the area. Make sure y'all read this part. All right, I have a rectangle, and within there's a hole, and that hole, based on the dimension 6 by 5, that will actually be another rectangle. So tell you what, I'm gonna just say I have a big rectangle outside minus, all right, cut out this hole, which is cut out the area of that small rectangle. All right, so this one is not that bad because I know the formula for the area formula for rectangle is both length times width. All right, so let's see. Big rectangle, 16-inch long, 7-inch wide. So that's 16 times 7 minus the small one, 6 by 5, which we know is 30. So let's see what my dimension turned out to be. 16 times 7 minus 6 times 5, which is 30. So my area, okay, my rest of the area will be 82 square inch. All right. Let's try another one. So this one is the hole right here is a triangle. So I have a big old rectangle with a triangle hole. So this 8 feet is indicating for the base, all right, of that triangle. So the 2 feet got to be the height. So for this area of the composite figure, that will be take the rectangle, which is the bigger area, right? Because the hole is inside the rectangle. So we subtract the triangle. So rectangle is length times width, but this time we're going to subtract off that hole. Half times base times height. Oh, too far down. Sorry. So that will be, well, let's see. My rectangle, 14 feet by 8 feet. So that's 14 times 8 minus half is 0.5 times area. The base of a triangle is 8 feet times the height, which is 2 feet. So let's punch it in. Once I write it out, I punch it in, so I don't have to keep on looking at the formulas, you know, and keep on looking at my calculator. So it's easier just write it out and then punch it in at one time. Minus 0.5 times 8 times 2. So that would be 104. All right, square feet. Okay. All right, this one. A triangle is cut off a parallelogram, so that means I have a triangle hole here. The base of a parallelogram, I'm going to go ahead and write it down. Okay, base of a parallelogram is 26 centimeters. The height of a parallelogram up and down here is 20 centimeters. The base and the height of a triangle are half. The base and the height of the triangle are half the base and the height of a parallelogram. So that means the base of the triangle is half of the base of the parallelogram, so that makes the base 13. The height is also half of the height of parallelogram, so that makes it 10. Respectively, what's the area of the figure after the triangle is removed? So that means I'm going to cut out this triangle hole again. So the area of my composite figure is going to be a parallelogram minus the area of a triangle. All right, so if you look at the formula sheets, the area of a parallelogram is always base times the height minus a triangle, which is half times base times height. So that would be 26 times 20 minus, all right, half is 0.5 times base of a triangle is 13 times 10. Okay. Let's see what it is. 26 times 20. That gave me 520 minus 0.5 times 13 times 10. So that would be 455. All right. What was my units? Square centimeters. Okay. So with all this wording here, it's just trying to tell me the dimension, okay, of my triangle that would need to be cut out. All right. So in this lecture video, we quickly talk about the area of a composite figure associated with our triangle, rectangle, square, parallelogram, and trapezoid. All right, that will conclude this lecture video. Thank you for watching.